Hi guys, for today's lesson we're going to be dealing with gradient intercept form. So what do I mean by this phrase of gradient intercept form? It's an equation that represents a straight line with y as the subject. So y is by itself in this equation. So it has this sort of form. So notice first thing I need you to see is that y is the subject. It's y equals something. And the form is mx plus c. Now the m represents the gradient of the equation, and it's always the coefficient of our x. You'll notice that the m is in front of our x. And there's a plus c on the end. That c stands for constant, and that represents the y-intercept of your line. So this form immediately will show you the gradient and the y-intercept. So let's demonstrate this. So I've graphed 4 different lines here, and I've got the equations for each one. So there's one equation, another equation. So we've all got the equations there. I want you to notice that the gradient for this brown line here is 2 over 3. It's uphill, so it's going to be a positive gradient. And you'll notice that that fraction of 2 over 3, which is its gradient, rise divided by run, that is in front of your x. That's the coefficient of your x, 2 over 3. This gradient can actually be, it can be used for all these lines. Like if I zoom in a little bit, if I grab this rise over run triangle, which is exactly the same, it can fit for all these lines. Like I can slide it along and it'll fit this this slope. So you can see this rise over run slope fits all these lines. They've got exactly the same slope. You'll notice that they're parallel lines. So so they all have the same gradient. And you can also see that from their equations. The coefficient of x each time is always 2 over 3. They've all got the same gradient with a rise of 2 and a run of 3. However, they do have very different y-intercepts where the lines hit the y-axis. So the constant on the end, so that's plus 4. Notice that it goes through the y-axis at 4. That's not a coincidence. This has no constant, so therefore its constant is it's like a plus 0 on the end, so therefore its y-intercept is at 0. This one has a minus 2 on the end. That's because its y-intercept is negative 2. And this one has a minus 4 on the end, and that is why its y-intercept is negative 4. So they're definitely not coincidences. You need to be able to link the properties of the equation to how the line looks on the graph. And notice that they're all in gradient intercept form because we've got y equals, like y is the subject. Okay, so let's do some example questions. So state the gradient and the y-intercept of the following equations. So we've got our equations here. The strategy is to ensure that y is the subject because that means it's in gradient intercept form. Okay, let's look at this first one. Y is the subject, so we've got it in gradient intercept form. You need to look at the coefficient of x for your gradient. So look at your equation. What's the coefficient of x? The coefficient of x here is the minus 5, so that is your gradient. And for the y-intercept, you look for the constant, the number by itself. That is just going to be our positive 4 here. So we figured out our gradient and our y-intercept. Okay, next up, have a look at this equation here. You have to think to yourself, is y the subject? No, at the moment it's 3y is the subject. You need to get y by itself, so we're going to divide everything by 3. That makes our 3y change to just y, which is what we want. X divided by 3 is x over 3, and 5 divided by 3 is 5 over 3. So we get this equation. This is in gradient intercept form because we've got y as the subject. So m is the coefficient of x. So we look at this and we think, what is our coefficient of x? Well, I know for a fact that x is the same as 1x. So like I could change it to a 1 in front. And so therefore the coefficient is going to be 1 over 3. You've got to make sure you consider your denominators as well. Okay, so our gradient for this equation is going to be 1 over 3. The y-intercept is our constant, and our constant is going to be 5/3. So we've got that there. So that's done. We figured out our gradient and our y-intercept, which is what we're after. Okay, question 2. Sketch the following equations using the gradient intercept method. We want to be able to sketch this. So in previous lessons, you would have used the intercept method, but here we're going to use the gradient intercept method. So the strategy is start by graphing the y-intercept, then apply the rise and run from that y-intercept. Okay, so we look at this equation and we think, well, our y-intercept is going to be -4, so we know that it goes through the y-axis at -4, and then you can make the appropriate rise and run triangle, which applies to 2/5, or -2/5. Okay, so our rise, so we can see here we've got the right y-intercept. I'll zoom in to show you. We definitely know that it goes through at -4. But our rise and run is -2/5 from this coefficient of x. So that means it's downhill because it's negative. And we know that the rise is 2 and the run is 5. Okay, so we've got to make sure we're rising 2, but because it's downhill, we're going to be going down. So notice from our y-intercept of 4, we've gone down 2 squares. I'm just going to slide this so it lines up with the grid a little bit nicer. Slide that down. That's a bit better. Okay, so so we can see that from our y-intercept of 4, we're going to go down 2 because the rise has to be 2 and it has to go downhill. And we need the run to be 5 because we've got a rise of 2 and a run of 5. Okay, so we've gone down 2 and then we're going to run across 5. And this makes the correct triangle, as you can see. So when we do that and we get the correct triangle, we end up here at this point. So you want to consider this as your first point and where you end up with your triangle as your second point. Use these 2 points to draw a straight line through them. So therefore you get your equation just like that. This line has the correct the correct gradient, and it also has the correct y-intercept. So that must be the graph of your line. Okay, let's try another. Y equals 4x. So this is the same as this. I can put a +0 on the end if I wish to show the y-intercept, and my gradient is definitely 4. So I'll start with my y-intercept of 0. So I know it has to go through this point, the origin, because its y-intercept is 0. And my rise and run is 4, because that's my gradient. Now that's positive, so it's definitely going to be going uphill. And 4 is the same as 4/1. So my rise is 4, and my run is 1. So from our origin, from this point here that we've started with, we want to rise 4, 1, 2, 3, 4, and we want to run 1. We end up at this point right here, and so we can therefore use this point and this point to make a straight line. So we just put a straight line through those points, and we get our equation. That is the line y equals 4x. Done. Okay, moving on. Question 3, determine the equation for the following line. So we can see this line, we want to figure out what is its equation. So the way to do this is to find the values of m, the gradient, and c, the y-intercept, for the form y equals mx plus c. We can literally put in our gradient and y-intercept into this equation, and we get the equation that we're after. Okay, so let's have a look at our line. So we can see that the y-intercept, c, is going to be right there, which is 4.5. It's between the 4 and 5. And so that's going to be 4.5 as our c. And we can pick 2 points that line up with the grid to make our triangle for our gradient. So I've picked that point right there and that point right there because they line up really nicely with these numbers. So we're able to kind of figure out what our gradient is really easily. So I've made a triangle with these 2 points to see the rise and run. I can see the rise is 1, 2, 3, and I can see that the run is 2 squares. So our rise is 3 and our run is 2. And notice how the line is going downhill, so it has to be a negative gradient. So our rise is 3, our run is 2, and then we put a negative in front for our gradients because it's downhill. So that is our gradient, and that is our y-intercept. So this can go straight into the formula. Notice that your m is the number in front of x. That changes to this. And our c changes to positive 4.5. So we go plus 4.5. That is the equation of our line. Good luck with the questions.